So to start off, my name is Ella Bianco. I'm co-lead of A&I, and I'm a freshman at American University in Washington, D.C.
And hi, everybody. My name is Akash. I recently graduated from North Carolina State University, and I'm a full-time software engineer now. Yeah, so let's just start off with what a prototype is. So it's essentially just a way to make your concept come to life, and you want your ideas to turn into something that you can either have in your hand or you can interact with or see. And this can allow you to kind of test different hypotheses or come across different ideas that may allow for your product to be better. So if you're prototyping and you realize, hey, material B is better than material A, that allows for your product to be a lot better. Second, prototyping kind of goes hand in hand with creating your minimal viable product. So while you're not exactly focusing on marketability, uh, well, you're not exactly focusing on marketability. We could definitely uh, allow for prototyping to test feasibility and see whether or not you're going to be able to create your prototypes or create the actual product that you're going to want to create.
Another really
Yeah.
important definition, real quick, is fidelity. Fidelity is an attribute of a prototype that measures realism, detail, and similarity to what you're trying to build, ideally in your mind. One level of fidelity isn't necessarily better than the other. It should really be an iterative process where you're starting at low fidelity and then building to high fidelity. Can also really help you save money, time, by building a lo-fi prototype at first and then scaling up to hi-fi. That's what my team did. We literally started off with Legos and ended up with a full-scale prototype. So, like, really a really helpful concept.
Yeah.
Let's talk
And yeah, and
phases.
prototyping phases can, you can kind of define how you want to start doing your prototyping. This is just a kind of, I guess, a pathway that we recommend here at Conrad. And it starts off with kind of listing your requirements. So you need to do a little bit of research into figuring out, okay, if I'm going to do a low fidelity prototype, what are the goals that I'm trying to build towards? You can talk to your end users who are going to be ideally using your product. Hey, like, what are we trying to build for you? You can talk to, like professors or your teachers, different mentors, or just think for yourself or brainstorm as a team. What are the requirements that you want to build for? And then from there, take those requirements and use that to design your prototype. Um, Again, depending on the complexity of what your prototype is going to be, this design phase can be really long or it can be really, really fast. And then the larger part is actually building your prototype. And once again, depending on the fidelity of your prototype, it can be a really long phase or it can be really short. And if you are doing an iterative process where you're going from a low fidelity prototype to a higher fidelity prototypes every time, ideally you'd be able to use your learnings from the previous prototypes to build even faster and build more efficiently. And then from there, you need to be able to find a way to evaluate or measure the success of your prototype. And that kind of goes back to your requirements. Does your prototype realistically, um, is it able to handle all of the requirements that you set out at the beginning that you wanted to solve? If not, then how important is that requirement for your prototype? And then from there, you can finalize that prototype phase and then restart the entire process with your next prototype and the next phase of your fidelity.
So let's talk about some tips and tricks. Really, really important to write things down. Personally, I forget everything. Not gonna lie. So, um, because this is a really rapid process, and let's be honest, you don't have much time, unfortunately. Um, like between now and when the round ends. So like really, really helps to be able to remember things, to write everything down that you're talking about. This can help you, especially with like measuring. If you're writing things down, you're going to have something to look back on when you're making a new model, that will help you really start to iterate on that concept and make it better in the future. If you wrote down like what worked, what doesn't work, just write down everything that you can. On a similar note, drawing out your prototype before you start can really help. I prefer something like lined paper or like a graph paper. It's what I always use. I am a big fan of graph paper. And then you can use that to kind of build your CAD model or whatever else you're doing. And I think it's really helpful to just draw out the assemblies, draw out the sub-assemblies, that really helps me personally before I put it on the software that I'm using. Another point is you're gonna want to fail fast, which it sounds kind of scary. Nobody really likes failure, but failing is not a bad thing. And we really have to emphasize that because when you fail, you're gonna find out what works, what doesn't work, and what you need to do better. And that's a great thing when you're prototyping. That's the entire point of prototyping. So, as quickly as you can get to that consensus, the better. And the more successful that you're going to be. And then just being able to like let go of some ideas if you realize that they don't work, is another really valuable skill. And just moving on with it really fast. And yeah, just making sure you're going fast, and then learning from it. Tying that into the next concept is they're very connected. So IBM has this thing called build, learn, measure, and that is just as it says. So they build a prototype, they learn from it, and then they measure the success, and then they do it all over again, in a really, really fast process. So you're gonna want to build out whatever you're building, collect data from it, figure out how it interacts with its environment, figure out how it interacts with its customer, and then figure out some sort of metric that you want to measure that with. And that can be really, really, really helpful when it comes to building your next prototype and your next iteration. I think a flowchart also really helps to map out how your user is going to interact with your design or how your design is going to respond to user inputs. And we can get into that in a little bit. Let's get into some software recommendations. So me personally, I am a big Autodesk fan. And there's a lot of different Autodesk software out there. Personally, I use Fusion 360. But that's not gonna, it's not everyone is going to use Fusion 360, and that's okay. There's a lot of different software that you can use. So I would say for the Autodesk software, it's in reverse order, from most to least user-friendly in here. Autodesk AutoCAD tends to be very overwhelming for me personally. And it's also a lot of resources for my computer to run. So unless you have some really, really specific use case that you need that for, I would not try with that one. But that's great for both 2D and 3D CAD and converting from both seamlessly. Autodesk Fusion 360 is like AutoCAD, but I think it's much more user-friendly personally, and I really like it. It's what I use for my prototype, and it also allows you to convert pretty seamlessly from 2D to 3D. Tinkercad is sort of a beginner platform. It's really, really helpful for getting people who might not know super much about CAD into CAD. And I've seen people use it for their prototypes. So that's certainly an option. Lucidchart is a diagramming software, and I've used this for like flowcharts for my prototype. I think it's really helpful. They have student accounts. Oh, Autodesk also has a student account. It's really expensive if you don't have the student account, but the student account is completely free, which is awesome. Onshape is an open source software, which is web-based, and that can also be really great. This is what I used in my high school. It's what they taught classes in, and I would say that honestly, it's a great platform, but it can be a little bit buggy. So, if you need like a cloud-based platform, then I would say Onshape is a great bet. But personally, I'm a little bit biased towards Fusion. Inkscape, which is the little ink fountain, is another really great option. This is just for 2D. It's a vector graphics software that allows you to create art without any quality loss. This is just for like 2D prototyping. I also think it's a really great logo design software. And then Blender, I love Blender. I can't talk about Blender enough. I've literally seen them use it at NASA, but it's another thing. Blender is completely open source. I prefer to use it for like stuff like rendering. It's what I rendered my prototype in. Although there are options for that in stuff like Fusion 360. There's just so many options for Blender, and it's completely free, and it always will be. So if you click on these, or just take a picture of these because it's going to be pretty important. These will take you to each of the different software's educational licensing websites. Should walk you through the steps pretty easily as well.
Yeah. All right, Ella, can we go back just a slide? Just give them a little couple extra seconds to, if you guys aren't able to take a picture, feel free to just copy down that tiny URL at the bottom. And from there, you'll be able to be linked to the actual software's website where you can download the software for free as a student. And if you have any questions or need any help on that, we can take any Q&A at the end of the meeting, or you guys can email us down the road as well. Yeah, so we can just go ahead and we'll put the links in the chat at the end. Actually, so that way everyone has access to it. And then here, let's go on to the next slide. Yeah, so obviously a lot of you guys are doing physical products, something you can hold in your hand, but you guys will also have to do some digital products in the form of your website. And some of you guys also want to augment your physical product with digital products as well. Or maybe your entire product is a digital product. And from there, we have some recommendations as well on how you guys can digitally prototype. And so we have three main kind of steps here, kind of still following the overall prototyping line that we talked about earlier. But kind of the same way, you start off planning, what features do you want to include? And then you can build a wireframe explaining, the outline for each component of whatever your product is, whether it's the website or an app, and how that interacts with each other. And then you finally build your website or your app or whatever your digital product is, and to take that wireframe and bring it to life. From there, once again, you can measure how effective it is by talking to your end users, talking to your mentors, just evaluating it as a team as to whether or not it fits all those requirements that you planned out, and then move forward from there. And just a couple examples of how you can create this wireframe. Here's an example for a sample app where you can use Lucidchart, as Alan mentioned earlier, or another really common digital prototyping tool is Figma, where we can see where you can basically plan out, for example, like on an iPhone, how the application or the digital product looks and interacts. And if I press this button, what will happen? If I press that button, what will happen? And all of those things should be planned out before you actually build anything. Go to the next slide. We have some software recommendations for different things that you guys can use for actually building your website or building a digital product. So Wix, Weebly, and WordPress are just a few of, I'm sure a lot of you guys already know about these, are just a few website builders that you can find online. And if you have the time, and you maybe you don't have the time to learn how to code, and that's a-okay, right? That's why these website builders exist, that would kind of guide you through the process of building this website, allow it to be responsive on all sorts of different screen sizes, and you can really focus in on your product rather than the actual website itself, or a digital product itself. Bubble.io, Framer, and Flutterflow are a little bit more intensive. In my opinion, they make a little bit better websites and digital products, but they are also low code or no code tools that would allow for you to create your digital product and make it look pretty awesome. And of course, if you know how to code and you're really familiar with those ecosystems and really want to make a fully functional website or app or anything, feel free to do that. And that won't necessarily give you more points when you're evaluating versus someone using Wix. But if you feel like if you need that functionality in order to show off what you can do and show off your product, then we definitely encourage you to do that. Ella, you're muted.
Ooh, sorry. Let's get into some troubleshooting. This can be a really stressful process, and we understand that. We've been through it even. So, we understand, and we're here to help. What we say is, I would just take a breath and take a walk as well. Can be very frustrating especially with programs like CAD. I get very into it. So just taking a walk and breathing are very important steps in the process. Just making sure that you can zoom out. And I know a lot of us are very detail-oriented people as well. So just making sure that you can come back to it with a set of fresh eyes. Zoom out. It's not, if something little goes wrong, it's not the end of the world. Like it'll be okay. When something does go wrong, it can be really helpful to check your software's respective forum. Chances are, if you've had the problem, somebody else has. If you have a mentor as well, it can be really helpful for them to take a look at your program to see if there's anything that they can see that is going wrong. So those are some really helpful things, in my opinion. So let's get into a little tutorial. So this right here is Fusion 360. This is my preferred software of choice. And it allows you to operate in this little 3D space. But another important aspect of it is that it's 2D as well. So you have to pick a plane, and then you can start building. Today we're going to be building a little door. First of all, it can be really helpful to sketch out your construction lines. So just making sure that you have a basis for whatever you're doing. These can help center your project and can help you to be able to, what's the word? Manipulate your project easier. Gonna make the frame now. let's say it's gonna end here. Oop, that's a construction line. Then we can make the door itself. We can also extrude this, both of these. Let's say we want to extrude them different amounts. We can go here. Let's say we want to extrude this 1/4 of a foot. Oh, that was not a quarter, but here you can operate your sketches. They disappear after you make one part 3D, so it can be very important to keep that on. And then now you have your door. But another thing that is really important is being able to make joints in your design. And for that, I'm going to make a simple hinge. Actually, what I'm going to do is go up, top, and make this oh, that's very tiny. Scale is also very important. Good note. Where let's just make this a really big hinge. So that's a bit too big. And then if we want, we can go back to the same sketch and extrude a new component up.
Yeah, and if you guys have any questions as Ella is doing this little demo, feel free to type in the chat and I'll be able to bring it.
Let's just say we have if you've ever seen a hinge, they have like that little place for the door to actually
Oh,
attach
this,
it. Do you have a question?
yeah, so one of the questions is what's the software you're using right now? The
This is,
Autodesk
yeah,
Fusion
Autodesk
360.
Fusion 360. And you guys can be much more precise with your measurements. This is very, very quick. And Yeah. Right now, what I'm going to do is make some joints between two of the components so they can move um, based on a hinge. Um, Component two is going to be this. Ooh. And the motion is going to be revolute. So as you can see right now, if you were to attach a door to this, this is revolving right now. And although there's no actual door attached to it, the door would be opening as the um top of the hinge changes or revolves around the other part. Another really important and something that we had a lot of questions about was how you can take a video of your digital prototype and then um, put that in your videos. And this animation workspace in Fusion 360 is a really, really cool um, piece of software that you can use. So you just go up to this little window right here and go into animation, which is what the workspace that we're in right now, and go into that. And later we can provide some resources on how you can use that. But for right now, that should just be a very, very basic tutorial, but you can have multiple sub-assemblies. This would be the main assembly altogether, but then these two pieces are both sub-assemblies. But yeah, that's a very, very basic overview of some of Fusion 360's capabilities.
Yeah. And Ella, we have a few questions for you.
Go
Um,
for it.
One is a question about, if there's so many CAD tools, how do we know which tool to use?
The best answer I can give you there is do whatever you're comfortable with.
Yeah.
Mess around with whichever one, or just start messing around in a bunch of programs and then get comfortable with some of them and use whatever you're comfortable with. That's the best piece of advice I can say. It took a while to find Fusion, and that's what I'm super comfortable with now. So
So
it's a little bit of a process.
exactly. And to add on to what Ella said as well, Akshat, I would definitely recommend also looking at different YouTube videos for all these different programs because from there you can have a general idea as to what you need to know in order to achieve the goals that you want to have, right? So if you're, for example, just building a door or just creating something 2D, you don't necessarily need to have a completely full out 3D program to show off. But if you want to do something super complex, like show off an engine design or something like that, yeah, you're going to have to put in a few more hours to learn exactly what tool you need and how you're going to be able to do that.
Yeah. Um, and some tutorials can definitely teach you better than um, this quick little run through. So definitely, definitely, definitely go look some up. There's some great tutorials on the internet. Um, and yeah, I would definitely suggest those. It's kind of how I learned.
And I guess we can kind of move into the Q&A section now
Yeah.
since we are approaching that. Um, let's see. So one question that has definitely come up pretty consistently was about whether or not you need a physical prototype or if CAD is okay. And the answer to that is, yeah, CAD should be fine. Um, the reason why we talk about physical prototypes is because if you're trying to turn your Conrad idea into real life, obviously, and a real business, which is kind of like the goal and the inspiration behind like um, trying to push you guys towards that. You know, a physical prototype is going to be necessary down the road. But specifically for Conrad right now, yeah, so CAD doesn't obviously replace the physical prototype, but you can use CAD to demonstrate, for example, if you're planning to build, or if your innovation is, let's say, like a new satellite design or something, we obviously do not think that you're going to go out and build an entire satellite. That would be pretty crazy for high school students or younger. But if you can design it in CAD or you can show off, a virtual model, that would be really helpful, especially during your innovation video where you're going to be showing off what you've done, or even on your website.
Yeah, to add on to that, even if you do just have a CAD model, that can very easily become your physical prototype through a process like 3D printing. And even if you don't have a 3D printer, that is completely fine. I don't have one. They get expensive. Check with your school. They might have one. Um, Even your library might have one. Um, Another thing you can look at is online 3D printing services where they will print your design and then mail it out to you. And some of those are exometry or materialize. Those can also be really helpful.
And another question we had was whether if you guys build an app, will the judges be using it, or will you just be able to show off the app functionality? Um, more likely the latter. So the judges obviously have the ability to interact with whatever you guys present with them. Um, but if you guys really, really want to focus in on a specific functionality or screenshots to demonstrate your value and demonstrate your product, then that's a-okay as well.
Yeah. Another thing to note is that you can't give anything to the judges. Um, so they're not going to be able to touch anything that you are making. And I would assume that includes an app. So just be aware of that. That's also a very important point.
Is a purely digital design innovation any better or worse than a physical one? And are there any advantages or disadvantages to doing it digital?
I would say no. I think that honestly, it really depends on what you're making. Um, and I would say that it's really just it's up to you and it's up to how good you think you can do with just a um digital prototype. But it's up to you. It's subjective. It can be helpful to have a physical one. And that can be achieved through something like 3D printing, but it's up to you. Akash, I don't know if you have any wisdom to add on to that.
Yeah, I mean, a lot of times too, the digital prototype or the CAD model, the computer aided design model is what precedes you actually building the physical prototype. And so it can kind of serve as a blueprint for you to actually build it out, make your life a lot easier when doing so. Um, and to answer the question about the innovation stage, do you need to have a CAD model? Do you need to have a digital prototype? No, you don't. Um, if you guys go to the student guide on the Conrad website, you'll be able to see that the three things that you need for the innovation stage are your innovation brief, your innovation video, and your website. And that's consistent throughout all the categories. Um, so in your innovation video, it definitely would help at times. If you're talking about a really complex design or if you're trying to talk about your product, it'll be awesome if people can see um, what product you're talking about, whether it's you holding it in your hands or you showing it spinning around in a computer design. And so, although it's not necessary, we definitely recommend it if you have the ability to do so. And it can definitely, help show how mature your product is and show how feasible your product is.
Definitely.
And Akshat, yes, judges can see the website. They can interact with the website. They can see the website. Um, but we're talking about like, if an actual prototype, they won't be able to like interact with it.
Yeah, just at Summit. You just can't give them anything at Summit.
See, was some people ask about data collection. So specific for aerospace, but I'm sure other categories as well. Sometimes data is super hard to obtain or to really collect. And yeah, so at that point, you just have to do the next best thing. And sometimes you can run simulations if you guys can on some data that you think is real or would simulate real life. Um, and although that's not ideal, basically at the end of the day, you need to show where those numbers come from, right? So if you're going to simulate data or if you're going to simulate um, I guess, a process or anything, you just need to be able to back up the numbers or back up whatever claims you make with some actual research. So if a research paper that you find online says, um, XYZ, then you can reference that in order to make your claims. But don't just make things up just because you think it's going to work.
Yeah, adding on to that, Fusion 360 and similar software also have simulation tabs. It's in the same place as the animation one. Um, Personally, I've never tried it out, but um, I think that you can definitely um, try to use that to um, get some data. It might not be super accurate, but um, surely conducting those simulations yourself will not help, will not hurt you.
And someone asked about not-for-profit services, and you know if you'll be able to compete with a not-for-profit service. Absolutely, you definitely still would be able to, and you just have to do a great job on the innovation brief and your submissions for the innovation stage. Conrad isn't judging you on profitability.
Yes.
Yeah.
For the alumni network question, um, I'd say if you choose to get involved, it's a great community. And um being able to stay in contact with all these people that you meet in Summit, um, it's just really awesome. It's awesome to see where they go, and what they're up to now, and then have that community of like-minded people who also are really passionate about business, innovation, science, and technology. It's just, I don't know, it's a great experience. I don't know if you have anything else to add, Akash.
Yeah, no, I've been a part of the alumni network for quite a while now, about almost 6 years. Yeah, it's been awesome. I definitely got a lot of mentorship through the alumni network. Kind of helped me be where I am right now professionally, and it's a consistent source of inspiration for whatever I pursue. And yeah, so going on to another question that we had, which did come up a couple of times, was uploading a CAD file to allow for judges to interact with it on a website. Um, yeah, so innately, it's going to be harder to do that just because some of your no-code tools, it's going to be hard to put anything up that's 3D in general. But there definitely are YouTube tutorials explaining, hey, like if you copy this HTML snippet, you can kind of force that into a Weebly site or a WordPress site, um, and it would be able to handle that for you. So it's definitely possible. Definitely recommend searching it up on YouTube, for example, or just finding an online forum which allows um, for you to find that step-to-step process to do that.
I
And
got a direct, oh, sorry.
go ahead.
I got a direct message that I think would be helpful to address, I guess, altogether. They asked if my prototype was fully functional at the January deadline, and if all the winners had fully functional prototypes. And the answer to that is no. While to both. My prototype was full scale, but it was not fully operational. There were still the actual components that would be doing the function that the device was designed for were not even installed yet, but they were sort of simulated through things like lights, and that helped to demonstrate the intent and feasibility of the product. I would say that no, not all the winners have fully functional prototypes. A lot of them had CAD models as their prototype, because some of what they're doing is some of the materials are hard to obtain in real life. For example, my project, we were using UVGI bulbs, which can be harmful if they're managed in the wrong way. So it's hard to obtain those, especially when you're a 16-year-old. And yeah, you do not have to have a fully working prototype.
And let's see, other questions, video submission, innovation stuff stage. All of those questions related to the materials that you guys are submitting can be found on the Conrad student guide. So if you guys go to the Conrad website and then find the student guide, from there it kind of tells you exactly what you guys need to fill out, exactly what questions you guys should be answering for each section of the brief. The main tips that we can give is to, when it says a maximum of 3,000 words, keep it a maximum of 3,000 words. Just kind of follow the rules that it outlines, and to keep it concise, right? You only have like a few words, a few hundred words to express your amazing product or amazing idea. And so you want to be really to the point. Don't write a lot of words if you don't need to, and just kind of really focus in on the core ideas of your product. Yeah. And there was another question about examples for product websites. So we don't have examples for product websites for Conrad specifically, because this is the first year that we are doing a website as part of the innovation stage. And so what we will recommend though is on the student resources library, there is a how to build a website little article that you guys can use to kind of build or to go off of how to build your website. You can find some best practices there. And we also recommend just looking at websites that you really enjoy, and say like, wow, like this is really cool. Like I wish, my product had this kind of design, and not just copycatting from them, but, be able to take inspiration from, little parts. So let's say like if you move your cursor around a little, oh, okay. So yeah, so you still have to make a website last year as well. So we don't have examples on the website right now, but we definitely recommend you looking at the student resources library for a how-to guide.
And we have some more resources coming up.
Let's see. Yeah, Vihan, you're definitely allowed to have external help for the CAD portion.
For a fully functional product and validation for it, I would say that like getting in contact, what I personally did with my team was we got in contact with several different companies that are pre-existing and that have a pretty big user base, and then asked to test our product on their so I guess it's hard to explain. We did like a cleaning robot for public transportation vehicles, and we contacted airlines and public transportation companies and we're like, hey, can we test our product on your cars? And a lot of them will be happy to help you. It can be really helpful to make a connection in the industry if you have one. And yeah, I would suggest trying that out and looking around to see if you have any connections or if anyone you know has any connections.
And when it comes down to validation, as Ella said, at the end of the day, it just kind of comes, talk to your end users, right? So if you are an aerospace company, reach out as much as you can through LinkedIn or Twitter or, social media, to
go down the road and explore it. I kind of want to, but then what you call it?
here, one sec. All right, there we go. So yeah, so just reach out to industry leaders, people that you ideally want to be using your product, and then you can get their feedback and you can validate your idea and kind of all the data that you collected. And let's see, is the innovation video similar to a business pitch? Yes and no. So you definitely want to be able to talk about like, hey, this is a business that we are able to build and everything, but also the innovation video, as the name implies, really focuses on the innovation. So, it's only 3 minutes, so you just have 3 minutes to talk about how you came up with your idea, what your innovation is, what problem it's solving, etc. Kind of all of those different things.
Yeah. While you guys are still on, you can still send questions, but I just wanted to tell you guys, please sign out this form before you leave. Tell us how we did today. We would love your feedback. But keep the questions coming. We can still answer them as well.